Hi all. Now we'll be learning about 2.5, solving linear inequalities. This section students tend to get a little iffy and uncomfortable with just because I feel like most students are intimidated by these inequality symbols, but I'll try to make it as straightforward as possible so that you can really build confidence in this material and get a really good grasp of it as well. So this inequality, just for some review, stands for less than. This is greater than. The less than is always the one when you're reading it left to right, has that little point. It's tiny, it's less. Whereas if you're reading it left to right and then it's open, think about it as a crocodile mouth. It's nice and large. It's greater than. And then the ones that have the lines under it, it's the same meaning, except there's an added thing to it. And the added thing is it's or equal to. So less than or equal to, greater than or equal to. And then we have our equal sign. You'll notice I have a closed circle and an open circle. It's always going to be closed if there's a line underneath it, or if it's equal. And then it's always going to be open if there's no line underneath. Now down here, we have some brackets, and this does not signify as much grouping as it does your ranges between values when we're looking at like domain and range of functions, or what our solutions are for number lines. And so soft brackets, aka our parentheses, mean that the boundaries are not included, whereas the hard brackets mean that the boundary numbers are. You'll sometimes get ranges where one boundary number isn't included while the other one is. And vice versa. Maybe that left-hand side is included, but the right-hand side is not. And then whenever you see negative infinity or positive infinity, aka are all real numbers, those boundaries are always going to be bracketed by a parentheses or a soft bracket. Last but not least, we have what's known as our union symbols and our intersection symbols. Our intersection is linked with the word and. And the way that I remember it is you can easily draw an A with our intersection, whereas our U for union is linked with or. So anytime you're looking at and, you're looking at, okay, what do both of these values both include? We're looking at shared values only. Whereas or, you look at everything. All of them. You're unionizing the groups. Okay. So our learning objectives for this section are being able to graph inequalities on a number line and to be able to solve linear inequalities. So graphing inequalities on the number line, we have two short paragraphs that I'll read for you guys. What number would make the inequality x is greater than 3 true? And it's just all values that are greater than 3, 3.1. 4, a billion, a trillion, 256,415, 413, 314, so on and so forth. Are you thinking x could be 4? Yeah, that works. Could x be 6? Yeah, or 37, or 3.001? All of these are potential solutions. Any number greater than 3 is a solution to this inequality. So we show all of these solutions on a number line by shading and including either open circles or closed circles. And we'll demonstrate that together in a moment. But because the number 3 itself is not a solution, we are going to have an open circle there, or some professors do the number lines in terms of parentheses and brackets. There'll be a parenthesis at that 3. So it's interchangeable. If you are comfortable putting a parenthesis there, I'll draw the number line really quickly. We have 1, 2, 3, 4. I do open circle, shade to the right. Those are all my solutions. Draw my arrow because it shoots to positive infinity. But some people just do that soft parenthesis and shade. Okay. Definitions page, being able to convert inequality form to interval form notation, which is utilizing your soft brackets and your hard brackets. The key being is once you get this inequality form, graph it on your number line so that you can really visualize what's going on. And then from there, you can very, very easily convert it to interval notation. So I'm going to find my 3. They did a parenthesis. I, again, also just like to do that open circle, shade everything to the right. So we're not including 3, which is why we have that parenthesis, but we're including all other values all the way up to infinity. And all infinities, whether it's negative or positive, will always be closed off by a soft bracket. Again, that symbol, which is like that sideways 8, just represents our infinity symbol. Okay. So this is putting everything together that I spoke out verbally on our objective page today, but what each of the inequalities stand for. I also included the whole not equal symbol because we'll probably see that every now and then throughout this course, especially when we are looking for restrictions of functions in order to evaluate what our domain of that function is. And then we have our open circle, also known as our soft brackets and parentheses, our closed circle, also known as our hard brackets. We have parentheses. Again, don't include the boundaries, and I included a nice, beautiful example here, whereas hard brackets do. Also included an example, and then I also stated that you can mix the two, parentheses and hard brackets. Highly, highly, highly recommend you screenshot this and print it out and glue it into your notebook. This will come in handy all throughout your college algebra and trigonometry course, as well as throughout pre-calculus and calculus. And then last but not least, let's touch upon our whole unions and intersections again. And so unions represent all of the solutions mentioned, whereas intersections, our end, only represents the values that overlap, the values that are shared. And so I put in an example of a union down here. We're representing both of these solutions, all values from negative infinity to positive to -2, and all values from 5 to infinity. And then this is just a notes section representing our whole parentheses and hard brackets shooting off to the right or shooting off to the left based off of the direction of the inequality. Okay, I think I lost my screen for a sec. Wait. Okay, perfect. So let's tackle our first example together. We want to graph each inequality on the number line and then write in interval notation. Always draw your number lines. We're looking at all values from negative infinity to positive infinity. negative infinity to positive infinity. And so for the first one, we have x is greater than or equal to -3. It's greater than or equal to, so we're going to have a nice closed circle and shade in all values to the right. Second one, we have x is less than 2.5. So this time it's going to be an open circle and shade all values to the left. And then the last one, we have x is less than or equal to -3/5. We're going to have a nice closed circle and shade all values to the left. We now want to put this into interval notation. So hard bracket, -3 to infinity for the first one. Soft bracket, -infinity to 2.5 for our second. And soft bracket, -infinity to -3/5 for our third. And there we have it. We're all set. Oh, I made a mistake on that last one. That should be a hard bracket. It's a closed circle. There we go. All right, let's look at example 2. Once again, we're going to go ahead and draw out our number lines. And we have x is greater than -3, but less than 4. X is greater than or equal to -6, but less than -1. X is greater than or equal to 0, but less than or equal to 2.5. So open circle, shade in between. Closed circle, open circle, shade in between. Closed circle, circle, and shade in between. Interval notation, we have soft bracket, -3 to 4, soft bracket. Next one, we have hard bracket, -6 to -1, soft bracket. Or the -1. And then finally, the last one, we have 2 hard brackets, 0 to 2.5. We're done. Keep it on there for another second. So this is what we learned so far. We have our soft brackets, aka our open circles. We have our hard bracket, aka our closed circles. We have the combination of both of them. And then if we were looking at it shooting to positive infinity, these are 2 different options. Shooting to negative infinity, these are 2 different options. Or negative infinity to positive infinity, we have all of our values. Okay. Our second objective for today, we are going to be able to learn how to solve linear inequalities. So same exact concept, it's just now we're involving a variable. Most commonly, our variable is going to be x. And so up here we have our formal definition of our linear inequality and all of the types of forms that you can see. We have some, these aren't examples. Oh, this is just showing us that if we want to manipulate the inequalities, we need to do it on both sides of the inequality. So if we're subtracting 5, we need to subtract 5 on both sides, and we'll realize that it does not change any of the rules. It just manipulates the numbers. Same with our addition property of equality. We can add 7, but if we add it to one side, we have to add it to the next, and it won't change the set of rules. Our left-hand side, if it started out being smaller than our right, then it will still continue to be smaller than our right. And so these are just the addition and subtraction properties of inequalities, making sure that you're adding it to both sides of the inequality or subtracting it. Now we also have our division and multiplication property of inequalities. And same exact concept, except there's an added rule, and the added rule is if you're multiplying or dividing by a negative, you need to make sure that the signs are flipped. So if we have A is less than B and C is less than 0, aka C is negative here, then our AC is now going to be greater than BC. So instead of it being less than, which is what we had before, our inequality flips direction. And same with that second scenario. We have it switching signs on us. Okay, so something to be mindful of. We reiterate it on this slide so that you really know that you must flip that inequality if you're multiplying or dividing by a negative value. If it's by a positive, everything stays the same. But it's negative, you have to flip it. So now knowing that, let's apply it to our example 3. We have A, B, and C. Part A, x minus 3/8 is less than or equal to 3/4. We have part B, 9y is less than 54. And then we have part C, negative 15 is less than 3/5 z. Okay, we want to graph the solution and write it in interval notation. Let's combine some like terms here for that A value. We'll add 3/8 to both sides utilizing our inverse operations. Notice that I'm multiplying 3/4 by a fancy form of 1 so that we can get that common denominator so that we can just add the numerators. And so we're looking at x is less than or equal to 9/8. Graph it on a number line from negative infinity to positive infinity. We have 9/8. We have a closed circle, all values less than that. And then finally put it in interval notation. And we're done. Let's jump to the next question. We divide both sides by 9. So we're just looking at y is less than or equal to 6. Let's graph this on a number line. It's an open circle because we're not including 6, and then we're shading all values to the left. In interval notation, this looks like all values from negative infinity to 6. And then we're done. And then our last example for today, or for this section, I think we still have a few more examples. We want to look at negative 15 is less than 3/5 z. and utilize our inverse operations by dividing both sides by 3/5. Negative 15 as a fraction is just negative 15 over 1. So when we keep change flip, we're essentially looking at negative 15 times 5, all divided by 3, is less than z. And so we can reduce this a little bit. 3 goes into 15 5 times. So essentially we're looking at negative 25 is less than z, or if you want to write it the other way, z is greater than negative 25. Either of these would suffice. So I'll box both of them. And then I'm actually going to maybe shrink this a little bit because we still have to graph out our values and then write in interval notation. So we're looking at all values from negative infinity to positive infinity, looking at negative 25, all values greater but not equal, so open circle. And in interval notation, it's a soft bracket, negative 25, all the way up to positive infinity, soft bracket. And we're done. Right? Let's keep on going. Example 4, we have solve each inequality, graph the solution on the number line, and write the solution in interval notation. So we have a part A and a part B. N over negative 2 is greater than or equal to 8. And then our second one, negative 13m is greater than or equal to 8. So inverse operations, we're going to multiply both sides by negative 2 because the opposite of division is multiplication. And now we have, we multiply by a negative. What happens to the inequality sign? It flips. And so we're looking at n is less than or equal to negative 16. Now let's go ahead and graph this on a number line. All values from negative infinity to positive infinity. We have negative 16, open circle. All values, is it an open circle? It's actually filled, right? Because we're including that negative 16, and we're including all values less than it. So our final results, negative infinity to negative 16. And we are done. Let's move to part B. Yeah, good. We're dividing both sides by a negative. So what happens to the inequality? Flips sides. And so we're essentially looking at all values of m less than or equal to 8 over 13. Let's go ahead and graph this. We'll put in our negative 8 over 13. And we're looking at all values that are less than or equal to it. So we're filling in that circle and shading to the left. So what do we have in interval notation? We have negative infinity all the way up to negative 8 over 13, hard bracket, and we're done. Another little notes page. We have most inequalities will take more than one step to solve. We follow the same steps we used in the general strategy for solving linear equations, but we make sure to pay close attention when we multiply or divide to isolate the variable. Because again, if we're dealing with negatives, the inequality is flipping sides, flipping directions. So let's look at example 5. We want to solve this inequality. We have 6y is less than or equal to 11y plus 17. I'm going to go ahead and combine like terms. Let's subtract 11y from both sides. So now we're looking at negative 5y is less than or equal to 17. And then we're going to divide both sides by negative 5. Ooh, dividing by a negative inequality sign flips our direction. And so we're looking at y is greater than or equal to negative 17 over 5. Now let's graph this out. So we're looking at all values from negative infinity to positive infinity. We're going to plug in our 17 or negative 17 over 5 right over here. We're including that negative 17 over 5, so it's going to be a closed circle. And it's all values that are greater than or equal to it, so we're shading to the right. In interval notation, this looks like negative 17 over 5, comma, positive infinity, soft bracket at positive infinity, and a hard bracket at our negative 17 over 5. And that's it. So we're getting a lot of good practice with these inequalities. This does conclude our section 2.5. I highly recommend you take a look at those additional problems from our homework as well as from our workbook so that you can get a really strong understanding of this section. Hope this was helpful. Let me know if you have any questions and take care. Bye.